In a given circuit, the current in the 8 ohm resistance is 1.5 amperes. What is the total current I flowing in the circuit? A 3 amperes, B 4 amperes, C 5 amperes, D 5.5 amperes. So when we go through the circuit, we find that this 8 ohm resistance and this 3 ohm resistance are parallel to each other. 8 ohm is parallel to 3 ohm. Since they are parallel to each other, we'll use the formula 8 into I1 is equals to 3 into I2, where I1 is already given to us as 1.5 amperes. We'll substitute the value as I1 as 1.5 is equals to 3 into I2. We'll solve this. 8 into 1.5 upon 3, 1.5 ones are, 1.5 twos are, 8 by 2. Therefore, I2 we get as 4 amperes. But over here, we have been asked to find out the total current and not I2. Therefore, total current I will be I1 plus I2, which is, I1 is given as 1.5, so therefore 1.5 plus 4, that is 5.5. Option D is the correct option. 2. 4 resistances, 10 ohm, 10 ohm, 10 ohm and 15 ohm form a Wheatstone's network. What shunt is required across 15 ohm resistance to balance the bridge? A 10 ohm, B 15 ohm, C 20 ohm, D 30 ohm. So over here, we have been given 4 resistances as 10, 10, 10 and 15. But if we wanted this Wheatstone's bridge to be balanced, R4 should have been 10 ohm. So here we like shunt 1 by S as 1 by 10, that's what it should have been, minus 1 by 15. What it is actually right now, it's 15. When you solve 1 by 10 minus 1 by 15, you get it as 1 by 30. 1 by S is 1 by 30. Therefore, S is 30. Shunt is 30. Option D is the correct option. In the given circuit, the current in the arm BD is A I by 2, B 0, C 2I, D I by 3. So this is a given Wheatstone's network and they have been asked the current between B and D. They have been asked the current over here. As we see, the bridge does 50-50 and 30-30. So over here in series there's 50-30 and over here also there's 50-30. So by this we come to know that it is a balanced Wheatstone's network. And when it is balanced, the current between B and D will be 0. There will be no deflection in the galvanometer. Option B is the correct option. Question 4. The Wheatstone's network is shown in the figure. If the key K is closed, then the galvanometer will A. Deflect on the left side, B. Deflect on the right side, C. Deflect on either sides, D. Do not show any deflection. So over here we have a Wheatstone's network. We have 20, 10, 40 and 20. So over here we have 20 by 40 and on this side we have 10 by 20. This is 1 by 2 and even this is 1 by 2. So 1 by 2 is equals to 1 by 2. This proves that this is a balanced Wheatstone's network. Since it is a balanced Wheatstone's network, there will be no current flowing between B and D. And if there is no current flowing, the galvanometer will not show any deflection. Option D is the correct option. Condenser of capacity 4 mu F is charged to a potential of 1000 volts. The energy the condenser is A 1 joule, B 4 joule, C 6 joule, D 2 joule. We have to find the energy of the condenser, which is half into CV square, half into C. Capacity is given to us as 4 mu F. So 4 into half into 4 into 10 raised to minus 6 into V square. Volt is given to us as 1000. 1000 is 10 raised to 3. But over here You are having square, V square, that is 10 raised to 3 square. So that will be 10 raised to 6. This will get cancelled and we will have half into 4, which boils down to 2. Option B is the correct option. A cell of EMF of 1.08 volts is balanced by a 216 cm length of potentiometer. What is the length of the wire that will balance a cell of EMF 1.5 volts? A 250 cm, B 290 cm, C 300 cm, D 310 cm. So over here we have been given EMF, let's say E1 as 1.08, EMF E2 is given to us as 1.5, and we have been given only one length. Let's name it as L1 as 216. Now we can use this formula. E1 by E2 is equals to L1 by L2. We have the values of E1, E2, L1 by L2. Over here we only have one variable L2 and we have to find that variable. We'll solve this and we'll get the answer as 300 centimeter. Option C is the correct option. In a potentiometer experiment, the null point is obtained at 140 centimeter from a cell of EMF 1.2 volts. With another cell of unknown EMF, the null point is obtained at 210 centimeter. The unknown EMF is A 1.5 volt, B 1.6 volt, C 1.8 volts, D 2 volts. So over here we have been given two lengths, one EMF and one EMF we need to find out. So let's say E1, that is the one EMF given, is 1.2. Length L1 is given to us as 140 and L2 is given to us as 210. Now by the formula we have E2 by E1 is equals to L2 by L1. L2 by L1 is 210 upon 140, which is equals to 3 by 2. And instead of E1 we can write 1.2 volts. Therefore E2 will be 3 by 2 into 1.2 volts. After solving this we get the answer as 1.8 volts. Option C is the correct option. Question 8. A potentiometer wire of length 400 cm has resistance of 8 ohms. If a potential gradient of 0.5 volt per meter is maintained throughout the length of the wire, the current flowing throughout the wire is A 0.5 ampere, B 0.25 ampere, C 1 ampere and D 0.75 ampere. So over here we have been given the length in centimeters as 400 centimeters. We'll convert it into meters. Therefore length will be 4 meters. We have been given the potential gradient as 0.5 and we have been given the resistance R is equals to 8 ohms. We have to find the value of current. We know that V is equals to IR. We have to find out I. Therefore I will be equal to V by R. But we do not have V. We have rho and L. We also know that V is equals to rho L. So I will be rho L by R, which is 4 into 0.5 by R is 8 ohms, is 8. When you solve this, you get the answer as 0.25 amperes. Option B is the correct option. Question 9. In a potentiometer experiment, the balancing length is found to be 1.8 cm for a cell of EMF 1.5 volts. What is the balancing length for a cell of EMF 1 volt? A 1 meter, B 1.5 meter, C 1.2 meter, D 2 meters. So over here we have been given EMFs E1 and EMFs E2 as 1.5 and 1. We have given EMF E1 as 1.5 and E2 as 1. Over here we have to find the length, so we'll use the formula E1 by E2 is equals to L1 by L2. E1 is 1.5, E2 is 1, that is equals to L1 by L2. Now over here we have L1 as 1.8, as they have given us the balancing length is 1.8, therefore 1.8 by L2. When you solve this, you get the value of L2 as 1.2 meters. Option C is the correct option. 10. Two cells of EMFs E1 and E2, where E1 is greater than E2, are connected in series so as to assist each other. The balancing length is 2.7 meter. When the cells are connected in series so as to oppose each other, the balancing length is found to be 0.3 meters. What is the ratio of the EMFs? A 1.1, B 1.25, C 1.5, D 1.6. So over here we have to find the ratios of the two EMFs, that is E1 by E2. We should know that E1 is greater than E2, and we have been given the lengths L1 as 2.7 and L2 as 0.3. So we will write L1 as 2.7 and L2 as 0.3. We will use the formula E1 by E2 is equals to L1 plus L2 upon L1 minus L2, which is equals to 2.7 plus 0.3 upon 2.7 minus 0.3. When you solve this, you get as 3 upon 2.4, which boils down to 1.25. Option B is the correct option. A potentiometer wire is 10 meter long and a PD of 6 volts is maintained between its ends. The EMF of the cell, which balances against a length of 200 cm of the potentiometer wire, is A 1 volt, B 1.2 volt, C 2.4 volts, D 1.5 volts. Over here we have the potentiometer as 6 volts. So then potential difference per meter will be 6 by 10, that will be 0.6. Therefore we have K as 0.6. Over here length is given to us as 200 centimeters, L is 200 centimeters. When you convert it into meters, you write it as 2. Okay, so now we have to find E. The formula of E is KL. K we have found out as 0.6, L is 2. Therefore 0.6 into 2 is 1.2. Option B is the correct option. Question 12. In a potentiometer experiment, two cells of EMFs E1 and E2, where E1 is greater than E2, are used in series and balancing the length is found to be 58 cm of the wire. If the polarity of E2 is reversed, the balancing length comes 29 cm. The ratio E1 by E2 of the EMFs of the two cells is A1 is to 2, B3 is to 1, C2 is to 1, D4 is to 1. So over here we are in series. We will find out the ratios A1 by A2 by the lengths given to us. L1 is given to us as 58 and L2 is given to us as 29. So we will first use the formula L1 plus L2 upon L1 minus L2. This is 58 plus 29 upon 58 minus 29. That turns out to 87 upon 29. When you solve this, you get 3 by 1. 3 is to 1. Option B is the correct option. Question 13. In a typical Wheatstone's network, the resistances in the cyclic are P is equals to 10 ohm, Q is equals to 5 ohm, S is equals to 4 ohm and R is equals to 4 ohm. For balancing the bridge, a resistance of A 10 ohm should be connected in series with P, B 10 ohm should be connected in parallel with P, C 10 ohm should be connected in series with Q, D 10 ohm should be connected in parallel in Q. So now we want to make this Wheatstone's bridge balanced. When you have a balanced Wheatstone's bridge, all the 4 resistances are in the ratio. So here I have 4 resistances. Let's name them as P by Q is equals to R by S. So here I will have a P, Q, R, and this is my S. So P by Q will be equal to R by S. My R and S, both of them are 4 and 4. Therefore this is 4 by 4. my Q is 5. So over here I need to make P as 5. But my P value given is 10. The given value of P is 10. So if I connect another 10 ohm resistance parallel to it, then 10 and 10 parallel will be 5, because it will be R1 into R2 upon R1 plus R2. That is 10 into 10 upon 10 plus 10. That is 100 by 20. That is 5. So for this to become balanced, we will need to connect a 10 ohm resistance parallel to P. Option B is the correct option. 14. In the following circuit, the current drawn from the battery is 2 amperes. If the 5 ohm resistance is replaced by a 20 ohm resistor, then current drawn from the battery will be A 0.5 amperes, B 1 ampere, C 8 amperes, D 2 ampere. So over here we have been shown as a circuit. Over here if we see, let's name these as A, B, C and D. So if I have A by B, that is this by this, it will be 2 by 4, 2 by 4, that is 1 by 2. And C by D will be 8 by 16, that is again 1 by 2. Therefore A by B is equals to C by D, because 1 by 2 is equals to 1 by 2. If both of them, the ratios of them are equal, it's a balanced Wheatstone's bridge. And since it is balanced, the current which was flowing before, the same current will also flow later. Therefore 2 amperes was flowing before, the answer will be 2 amperes. Option D is the correct option. A wire of length 3 meter connected in the left gap of a meter bridge balances a 8 ohm resistance in the right gap at a point which divides the bridge wire in the ratio of 3 by 2. What is the length of the wire corresponding to the resistance of 1 ohm? A 1 meter, B 0.75 meter, C 0.5 meter, D 0.25 meter. So let's take a length of X. Let's divide it by 8, because over here I have the 8 ohm resistance. Now this gives me the ratio as 3 by 2. Therefore X by 8 is equals to 3 by 2. Therefore X will be 8 into 3 by 2, that is 24 by 2, that is 12. So I have got X as 12 ohms. Now for a resistance of 12 ohms, I have the length as 3 meter, because length is given as 3 meter. Then for resistance of 1 ohm, my length will be how much? For 12, it is 1/4 of what the resistance is. Therefore, for 1, it will be 1/4 of what it is. Therefore, this will be like 1 by 4. 1 by 4 is 0.25. Option D is the correct option. In a Wheatstone's network, the positions of the battery and the galvanometer are interchanged. The balance condition A remains unaltered, B alters, C may or may not alter depending on the resistance of the galvanometer and the battery, D none of these. So over here, I will make a Wheatstone's bridge. In this Wheatstone's bridge, now they have said, let's make a galvanometer for now. So if I have a balance condition, so my R1 upon R2 and R3 and R4, if my R1 upon R2 is equals to R3 upon R4, then the current will pass through here and there will be no current passing through this. Let's name this as BD. There will be no current passing through BD. Since there is no current passing through BD, the reflection for the galvanometer will be 0. This BD acts as an insulator or an open circuit where no current is passing through it. So instead of galvanometer, if we put a battery, again it won't make any difference because no current is passing through it. Therefore, the balance condition will remain unaltered. Option A is the correct option. Question 17. A cell of EMF 2 volts and negligible internal resistance is connected to the potentiometer wire of resistance 10 ohm and length 4 meter. The potential difference per unit length potential gradient of the wire is A 5 volt per meter, B 10 volt per meter, C 0.5 volt per meter, D 1.5 volt per meter. So here I'll have I is equals to 2 by 10 because V is given to me as 2. So this turns, and I have resistance R as 10. So V by R. So V is 2 and resistance is 10. So I get I as 0.2. Therefore, V by L, that is asked, that is potential gradient, would be IR by L, that is 0.2 into 10 by 4. When you solve this, you get the answer as 0.5 volt per meter. Option C is the correct option. A is the cross-sectional area and P is the specific resistance of the potentiometer wire. If I is the current passing through the potentiometer wire, then the potential gradient along the length of the wire is given by A, IA by rho, B, IA rho, C, I rho by A, D, I by rho A. So over here, we'll apply Ohm's law, and from Ohm's law, we have potential difference, that is V is equals to IR. Correct. Now the same IR can be written as I rho L by A. Therefore, my potential gradient which is given by V by L will be, over here we have got the value of V as I rho L by A. So it will be I rho L by A, and the potential gradient is V by L. So we'll have this L down here. L gets cancelled. So it is I rho by A. Option C is the correct option. Question 19. What is the potential difference between the ends A and B of the given potentiometer wire in the following circuit? The galvanometer G shows no deflection. A 1.5 volts, B 2 volts, C 2.5 volts, D 3 volts. Over here we have to take into consideration that a galvanometer is showing us no deflection. So now we have 60 meters over here, 60 centimeters over here. For 60 centimeters it is 1.5 volts. Then between A and B the length is 100 centimeters. For 100 centimeters it will be how much? So let's write that PD across 60 centimeters is 1.5 volts. Therefore PD across 100 centimeters will be how much? So we'll do this 100 into 1.5 upon 60, that is 100 into 15 upon 600. So when you solve this, you cancel out the zeros and you get 15 by 6. When you solve this, you get it as 2.5. Option C is the correct option.
Question: Kirchhoff's junction law is equivalent to, or Kirchhoff's first law is. So as we know, Kirchhoff's law states that if P is a junction and these are currents approaching the junction, I1, I2, I3, I4. So if I say I1 is towards the junction, I2 is away from the junction, I3 is again towards the junction, and I4 is away from the junction. Current approaching the junction or going towards the junction are considered to be positive towards the junction, and away from the junction are considered to be negative. This was nothing but Kirchhoff's junction law or Kirchhoff's first law. So it is nothing but conservation of charge, that is summation of I is equal to 0. So that is option B. So option B is the correct answer.
Question 21. A cell of EMF 4 volt and of negligible internal resistance is connected in series with a potentiometer wire of length 400 cm. The EMF of the Lagrange cell is found to be balanced at 150 cm from the positive end of the potentiometer wire. What is the EMF of the Lagrange cell? A 1 volt, B 1.5 volts, C 2 volts, D 2.5 volts. Over here we will use the formula V by E is equals to L by N. Over here we are supposed to find V, EMF, V, so V will be equal to L by L, this E will go up, L by L into B. L by L, we have been given the values of both the L's. The small L is given to us as 150 centimeters and the capital L is given to us as 400 centimeters and the EMF is given to us as 4 volts. When we solve this entire thing, we get the answer as 1.5 volts. Option B is the correct option. 2. In the Wheatstone's bridge shown below, in order to balance the bridge we must have, so this is the bridge which is shown to us below, and these are our options. A, R1 is equals to 3 ohms, R2 is equals to 3 ohm, R1 is equals to 6 ohm, R2 is equals to 50 ohm. C, R1 is equals to 1.5 ohm, R2 is any finite value. D, R1 is 3 ohm, R2 is any finite value. So if I have a balanced Wheatstone's network, I know that R1 by R2 will be equal to R3 by R4. Or in other words, I can say R2 by R1 will be equal to R4 by R3. Now while we'll substitute these values, we get 10 upon R1 is equals to 30 by 9. And when you solve this, you get the value of R1 as 3 ohms. So over here in option A, I have R1 as 3 ohms. In option D, I have R1 as 3 ohms. So B and C get ruled out on their own. Now I have to see the value of R2. Now when the bridge is balanced, no current flows through B and D. Through B and D, there will be no current flowing between this. Hence the resistance of the part BD does not affect the balance. Hence R2 have any finite value. So this R2 will have a finite value because over here the resistance will not affect. So R2 is given as any finite value in option D. Option D is the correct option. Question 23. The Kirchhoff's first law and second law are respectively based upon the conservations of A, charge momentum, B, energy charge, C, momentum charge, D, charge energy. So the Kirchhoff's first law states that the current passing, that is going out from any junction, will be equal to the current coming inside any junctions. For example, over here I have a circuit and this is my junction A. If 2 amperes pass from here and 2 amperes pass from here, so total 4 amperes are leaving the junction, which will go round the circuit and come back over here. Even this will go round the circuit and come back over here. 2 plus 2, that is 4. So if 4 is outgoing, then 4 will be incoming. So this is the conservation of charge. The first law is conservation of charge. So option B and C get ruled out. Kirchhoff's second law states that the sum of the EMFs of the whole entire circuit is 0. So if I have a circuit V1, V2, V3 and V4, then when I add it V1 plus V2 plus V3 plus V4, this will turn out to be 0. That is, the total energy is being saved. Therefore option D, charge and energy, is the correct option. Exists across a potentiometer wire of length 4 meter when the PD across a 2 ohm resistance of a second circuit is measured. By this potentiometer, the balancing length is found to be 4 cm. The current in the second circuit is A 1 milliampere, B 10 milliampere, C 100 milliampere, D 15 milliampere. So first let's go through the potential gradient. The formula of potential gradient is dV by dL. The volt is given to us as 2 volts upon the length is given to us as 4. 2 by 4 boils down to 1 by 2. Then they have given us the second circuit length as 4 centimeters. The length of the second circuit is found to be 4 centimeters. Now the potential difference or the voltage that we will find is 4 into 10 raised to minus 2. 10 raised to minus 2 is converting centimeters into meters into half. This turns down to 2 into 10 raised to minus 2. We are supposed to find out the current in the circuit. Current is I. We have the formula V is equals to IR. Therefore I will be V upon R. V we have already found out as 2 into 10 raised to minus 2 upon R is already given to us as 2 ohms, 2 ohm resistance is given to us. Therefore, I boils down to 10 raised to minus 2 amperes, which is basically 10 milliamperes. Option B is the correct option. 5. Sensitivity of a potentiometer can be increased by A. Increasing the length, B. Increasing the potential difference, C. Decreasing the series resistance, D. Increasing the current in the potentiometer wire. So now we all know that sensitivity is inversely proportional to potential gradient. So if my potential gradient will decrease, my sensitivity will increase. Now what is the formula of potential gradient? Potential gradient is equals to dV by dL. So we can see that potential gradient is inversely proportional to the length. So if I increase my length, my potential gradient will decrease. If my potential gradient decreases, my sensitivity increases. In the question, we have to find out how my sensitivity increases. That is by increasing the length. Option A is the correct option.